Hey guys, this is Mrs. Scott, and I am so excited to give you your first video notes lesson of the school year. This should be pretty quick. It is just an introduction. We will talk more about these notes in class together, but I just wanted to give you guys a little kind of idea of where we're going to start going in our first day of actually doing math. Good thing is, there's not a ton to actually take notes on in this lesson. I'm going to just talk for a little bit, and I am going to do 2 examples with you before we're done here, and we'll just pick up with the rest of it in class when I am Zooming with you next. So, the first topic we're going to talk about are types of numbers. So just like in the animal kingdom, when animals are classified, numbers can also be classified, okay? The animal kingdom example, kind of bad because I really don't know the classifications. Like, I know mammals and reptiles, but beyond that, not so sure. However, I know a lot more about numbers, so let's get into it. All numbers in the world are considered to be complex. Complex numbers are like the big umbrella that all numbers are under. So it includes real and imaginary numbers, okay? So from there, oh, by the way, here's some examples. Anything with an I is an imaginary number, and we're gonna have a whole unit on that in the future, okay? Every other number that doesn't have an I in it is called a real number. So with that said, from complex numbers, we either have real numbers or imaginary numbers. They cannot be both. You cannot be real and imaginary at the same time. It is one or the other. So imaginary numbers, as I said, they have to have that I. Now, one of these examples doesn't have an I. Why? Well, you guys remember back in the day in regular Algebra 1, we could not square root a negative number. Welcome to Algebra 2, okay? We are going to square root negative numbers. However, those are going to be imaginary. The solutions don't actually exist. However, if we play with the properties of imaginary numbers, we can come back to real numbers. It's a little bit crazy. It's also a little bit fun. We're going to do that in a future chapter. Moral of the story, imaginary numbers will have an I or will have a negative under the square root. Okay, those are the 2 types of imaginary numbers you're going to see. Every other number in the world is called a real number. All of these are examples of real numbers. They could have roots, they can have exponents, they could have negative signs. They're all real, okay? All right, now moving on. From real numbers, we can further classify. All real numbers are either rational numbers or irrational numbers. Cannot be both, one or the other. Rational numbers can be written as a fraction or a terminated decimal. Terminated means it gets cut off, or a repeating decimal with like a pattern. So when we put that bar over a number, that's a repeated decimal. Or if I had something like 5.252525 and a pattern repeated, that would be considered rational because I could technically write that repeated decimal in a fraction. So all fractions, all patterned decimals or repeating decimals, and all terminated decimals, okay? So just, maybe 1 spot, 2 spot, 3 spots, they get cut off. Those are all called rational numbers. Everything else in the world is irrational. Let me give you some classic examples. One irrational number is pi. Think of the word as irrational as like there's no rhyme or reason. It is random. The numbers don't make sense. There is no pattern to it. And key thing here, it goes on forever. That ... needs to exist. Another famous irrational number is the number e. It's something we're going to use a little bit more this year. You've probably never seen it before, but it is an irrational number. Again, it's a decimal. We all know pi is 3.14, but it goes on forever. And then there's e, which goes on forever too. It's 2.71 something. Okay, and then we got root 5. Any square-rooted number that is not a perfect square. Perfect squares are like 4, 9. Square root of 9 is 3. Square root of 4 is 2. Those work. But I cannot square root 5 nicely. It comes out ugly. There's a lot of decimals. That's irrational. There's no rhyme or reason to square-rooted numbers, decimals. They're random. Okay, so again, we got rational or irrational. Moving on, we can further classify rational numbers. If they're irrational, you're done. That's as far as you can classify. However, rational numbers we can classify as integers. Integers are positive or negative. Like, I think of them as kind of whole numbers. Technically, that's not the wording because whole numbers are only positive. But numbers that don't have decimals or fractions, positive or negative. So, -8 is an integer. -1 is an integer. 0 is an integer. Any positive whole number is an integer. Speaking of positive whole numbers, all integers that are positive or 0 are whole numbers. Okay, so those are just positive numbers. We include 0. And then there's, last but not least, the natural numbers. These are also known as the counting numbers. I think of it this way. If I tell you right now, start counting, go. What did you start with? You didn't start with 0, okay? If you say, oh, I'm going to start counting 0, 1, 2, that's a little weird. No offense. Like you anyway, but it's a little weird. When we start counting, we start with 1. So natural numbers start with 1. They do not include 0, only positive. Whole numbers, all positive, include 0. Integers, positive, negative, no decimals, and then so on and so forth. We got the rationals, irrationals, reals, imaginaries. Everything's complex. What up? What are we going to end up doing with this? I'm going to give you this crazy looking chart, and I'm just going to have you make some check marks. The number 4 is, let me go backwards. I start with complex. Of course it's complex. I could put a check for all of these for complex. 4 is not imaginary. So don't put an X, just don't put anything. Okay, obviously it's not imaginary. 4 is real. Okay, 4 is rational. 4 is an integer, a whole number, and natural number. FYI, for this chart, you cannot have both irrational, oh man, I'm off my game, guys. You cannot have both irrational and rational checked. That's impossible. And samesies with real and imaginary. Can't have them both checked. It's one or the other. All right, moving on. The classic example here, if I asked you to list some of these numbers, list all the rational numbers, the integers, so on and so forth. I'm not going to do every single one of these. We'll finish these in class, but let's go ahead and do the rational numbers together. 9/3 is rational. Okay, because it's a fraction. -6 is rational because I can write that as a fraction, -6/1. 0 is rational. E, that's an irrational number, no can do. Root 12, guys, I cannot square root the number 12 nicely. Impossible, no can do, it is not rational. -√9, that's imaginary, it's not rational, and 11/3 is a fraction, so it's rational. So that's really all that you're doing for these examples, and we'll finish these, the rest of these in class together as a recap. Last thing I'm going to talk about quick, order of operations. Please excuse my dear Aunt Sally. I know y'all heard that before. I don't know why I said y'all. I'm not from the South. It felt right. The order of operations is parentheses, exponents, multiplication and division, and addition and subtraction. Couple things. When I say parentheses, I mean all grouping. That includes brackets. If I have a square root, not the actual act of square rooting, but if there's operations underneath the square root, that's a type of grouping. So I would do everything under the square root first, then I would take the square root. Believe it or not, a square root is actually an exponent. You know, obviously squaring, cubing, and so on, but cube rooting, square rooting, those are all considered exponents. Another thing about grouping, guys, if I have like a fraction, everything on top of the fraction, even if there's not parentheses, that's grouped. So pretend like there's parentheses there. So that all falls into grouping. We talked about exponents. Multiplication and division, FYI, these can be swapped. You gotta go left to right for this. Okay, and I'm gonna have an example of that in just a second here. Why can it be swapped? I want you guys to think about this. It's trippy. Here we go. Multiplication and division are the same thing. Division is multiplication. What is she talking about? Here's what I'm talking about. You don't have to write this down. But 10 divided by 2 is 5. We all know this, okay? Here's the thing. I can turn that into multiplication because Division is just multiplying by a fraction. I am pounding on my table as I say that because that's all it is. Division is multiplication. It's the multiplication of a fraction. 10 times a half is 5. Half of 10 is 5. Division is multiplication. Same story for addition and subtraction. Subtraction is addition. That's why the order doesn't matter. We can swap it. We can do subtraction before addition. We just got to go left to right. So what do I mean? How is subtraction the same as addition? Okay, well, 10 minus 2 is 8, right? How can I turn that exact same thing into an addition problem? 10 plus negative 2 is 8. Subtraction is just adding negatives. Okay, that's all it is. It's addition. It's the addition of negative numbers. Crazy, crazy, crazy. But that is the truth. That's why we can swap. All right. So I'm going to do one example with you here, and then we'll be done for the day. Here it is. I'm going to do example B with you. Okay. Now, I mentioned this earlier. Even though you don't physically see parentheses, everything in the numerator of a fraction is grouped. So I'm going to start there. Now, if you already started doing 5 times 4, you're wrong. Why? Because division and multiplication can be swapped. And I have to go left to right. So I'm actually going to do this division first. 15 divided by 5 is 3. And I'm just going to write the rest of the problem so I can stay organized. I'm kind of working my way up here. Next, left to right, 3 times 4, 12. Divided by 6 minus 8. I'm just going to keep working up because it's looking good. 12 divided by 6 is 2 minus 8, and I'll finish the problem down here. 2 minus 8 is negative 6. Done with the top. Let's go down low. We got, okay, minus negative 5. Negative 6 minus negative 5. Minus a negative turns to a plus. So I got negative 6 plus 5 minus 8 divided by 2. Oh! I screwed up. And I'm not starting this video over. So we're just going to go with it. We're going to go with it, go with it, go with it. I should have done the division first. Okay, rookie mistake, that's okay. 8 divided by 2 is 4. Now it's like it never happened. Okay, so now I've done that. The minus a negative, I turn to a plus. We're still good. Now I go left to right. Sorry about that, guys. But there is a saying on my wall in my classroom. You can't see it, but it does say, Mistooks. Oh, my God. Okay, it's 8:38. I'm sorry, it's been a long day. Mistakes are proof that you are trying. So obviously I'm trying really hard right now because I've made a lot of mistakes. But hey, you know what? I'm human. It's all good. Here we go. Negative 6 and 5 is negative 1. Minus 4 is negative 5. That's my denominator. And negative over negative, those negatives are going to cancel out. Here's my final answer, 6/5. And I think that we can all agree on one thing for sure. I got to be done because, wow. Welcome to class. I'm so excited to work with you guys. Hope you enjoyed our first video.